I'm going to turn my attention to number patterns. All right, these were notes that I used last year. These were notes that I used for grade 12 number patterns. It was late, very late. Yeah, 25 minutes past 11. It's your time. It's very late. Just gonna check. Right, I think this is where we actually need to pump things up, because to be honest, it is geometric sequences that had a video that just gonked midway. So I actually need to take this through and see how it materializes, because it makes no sense. What did we say here? Geometric sequence. Sure. Alright. So it's supposed to be geometric sequence. Okay, geometric sequence is a sequence whose ratio between consecutive terms remains constant. So it's that. Geometric sequence is a sequence whose ratio between consecutive terms remains constant. Okay, so that's a geometric sequence. A sequence where the ratio between the consecutive terms remains constant. Let's see if we can establish very good, solid understanding. Yeah, so guys, I actually have videos that I compiled last year on sequence and series. You can find them on my YouTube channel. There's a playlist, it's called grade 12. But I realized when I was going through the videos that my geometric sequence video does not, I don't know, it cuts itself, which means somehow when I uploaded it, it just did not complete. So I tried to find the notes that I used from last year so that I can actually, yeah, those would be notes that I used early this year when I did the live lessons for the grade 12s that are 2025, the 2025 cohort. So I'm just trying to make sure now that I complete that video, or at least let's start it from the beginning, and then the content of the video, at least have that covered. So I'm gonna go through a geometric sequence. All right, grade 12, term 1 is sequence and series. You guys do a revision firstly. Let me just give you guys a bit of a recap. So grade 12, you guys first do a revision on quadratic sequence, because in grade 11 you did quadratic sequence. You guys know what a quadratic sequence is. It has a general term of Tn is equal to an squared plus bn plus c. That's from grade 11, term 3. Okay, you guys did this already. You looked at the original sequence of a quadratic sequence, obviously. You know, in terms of a, b, and c, you could substitute term 1 there and you can see what results. It's a plus b plus c. And then your first difference is an arithmetic sequence. Okay. And then your second constant difference, your second difference is actually constant. Okay. And if you remember, guys, when you wanted to solve for or get the nth term for a quadratic sequence, you would use these expressions. 2a is equal to the second constant difference, 3a plus b is equal to the first term in the first difference, and then a plus b plus c would be equal to the first term in the original sequence. Then you'd solve for a and b and c, and then you'd substitute them back into the nth term and get Tn. Okay, so this is quadratic sequence. So what I'm saying is this here, this content for grade 12, guys, is actually content that you can find on my YouTube channel. I've already covered this content already, all of it. Okay, what I wanted to really focus on today, grade 12s, is geometric sequence specifically, because I realized that in the videos that I have, I don't have the geometric sequence completed. So I'm going to go over it, okay? So what is a geometric sequence? A geometric sequence is simply a sequence or a number pattern where, and this is the key word, where the ratio, you see now this word ratio, okay, there's the word rational, all right, and the root word for rational is ratio. Now, what is a ratio, guys? A ratio is simply a comparison between two quantities. So for instance, 5:8 is a ratio. 5:8 can also be written as a fraction, 5/8. Okay, I hope you guys understand that a geometric sequence is a sequence where the ratio, now by ratio, what do we mean? We mean, like I said, either 5:8 as a ratio in this sense, or you can write the ratio 5:8 as 5/8. It can be written as a fraction, because rational, the word rational number is a number that can be written as a fraction, where the numerator and the denominator are integers. So that's why I'm saying the word rational has its root as a ratio, and what a ratio is can either be written as 5:8. If you are looking at an example, 5:8 can be written as 5/8. So a ratio can be written as a fraction. Okay, so we say a geometric sequence is a sequence where the ratio between consecutive terms remains constant. What is constant between the consecutive terms for a geometric sequence? It is the ratio between the consecutive terms. It is constant. So grade 12s, what we do then when we are calculating the ratio of a geometric sequence, the minute you are told that a sequence is geometric, then it means that you can take the second term, T2. By T2 we mean term 2. By T1 we mean term 1. You can take term 2 divided by term 1, and you should find that if you take term 3 divided by term 2, if you take term 4 divided by term 3, you should in essence get the same ratio, which we say is constant. Because for a geometric sequence, what is constant? It is the ratio that is constant. Okay, now here we can go further. In a geometric sequence, we have the following as well. We have a general term, which is Tn is equal to AR to the power n minus 1. Okay, edits, you can figure it out yourself. Okay, like I said, we have the general term, which is Tn is equal to AR to the power n minus 1. Now the A in a geometric sequence, what does it stand for? The A. The A stands for the first term. So A here means the first term. R here means the constant ratio. Okay, and how do we calculate the value of R? As I said to you, if it's a geometric sequence, it means that the ratio is constant. Therefore, you can say term 2 divided by term 1, and you should be able to get the same value for term 3 divided by term 2, the same value for term 4 divided by term 3, the same value from term 5 divided by term 4. Yeah, so all in all, guys, Tn is equal to AR to the power n minus 1 is what we call the general term, all right, or the general formula, or the general sequence of a geometric sequence is Tn is equal to AR to the power n minus 1. Let me just go back again. So what am I saying to you? A geometric sequence is a sequence where the ratio between the consecutive terms is constant. Okay, my grade 12s? The sequence where the ratio between the consecutive terms, consecutive means one after the other, one term after the other. The consecutive terms have a constant. The word constant means the same. It has the same what? Same ratio. What is ratio? Ratio means fraction. Okay. Hence we say, if we take term 2 divided by term 1, we should get the same value for term 3 divided by term 2, the same value for term 4 divided by term 3. That is what we mean by a ratio that is constant. These should give us the same ratio value. So in a geometric sequence, we have the general term, which is given by Tn, which is the nth term, which is equal to A. What is A? A is the first term. That means the first term. R, which means the constant ratio. And remember, the constant ratio is calculated by term 2 divided by term 1, or we could say term 3 divided by term 2, my beloved grade 12s. So Tn is equal to AR to the power n minus 1. That is the general term of a geometric sequence. Okay, now let's look at an example. Let us consider the sequence 3, 6, 12, and 24. Now you should notice something about this type of sequence. What kind of sequence do we see here? 3, 6, 12, 24. What is the behavior of this sequence? From 3 to get to 6, from 6 to 12, from 12 to 4, we have term 1, term 2, term 3, and term 4. What is happening in the sequence? Well, surely we can say that the first term in our sequence, in other words, A, T1, is actually equal to 3. What do we notice about the behavior of the sequence? From 3 to get to 6, from 6 to get to 12, from 12 to get to 24, what is happening here? Are we adding a certain constant value, or are we multiplying a certain ratio? Okay, Yolanda is saying we are adding 3. Yolanda, look at this. 3 plus 3. If we add a 3 to 3, we get 6. But if we add a 3 to this 6, we don't get a 12, because 6 plus 3 is 9. So it does not seem like we are adding a constant value. So in other words, this sequence is clearly not an arithmetic sequence. It's not a arithmetic sequence. I just want to go back a little bit here so that we can clarify what I mean by that. Okay. What did I just say? I said this is clearly not an arithmetic sequence. What do we mean by arithmetic sequence? We mean a sequence. Arithmetic sequence is a sequence where the first difference between the consecutive terms remains constant. So we'd say T2 minus T1 to get the constant difference, or we could say T3 minus T2, or we could say T4 minus T3. When the difference is constant, we say that type of sequence is arithmetic. And therefore, the general term is completely different from what I've just explained as far as its general term. For an arithmetic sequence, the general term is Tn is equal to A plus brackets n minus 1, close the brackets, times D. So this is an arithmetic sequence. What we are looking at now here is not an arithmetic. Apelele in the comment section, loquacious dime, oh my goodness, the word Yolanda, O, Keys, Junior, Yolanda. Okay, so guys, we can see here, and people have been saying, from 3, thank you Flores for the rose, from 3 to get to 6, we are doing something completely different. We are not adding or subtracting a certain number, but we are doing what, guys? We are multiplying by a certain ratio to get to 6, from 6 to get to 12, and from 12 to get to 24. What is that? It is very clear, guys, that our constant ratio is actually equal to 2. Okay, does that make sense? From 3 to 6, we are multiplying by a constant ratio. So 6 divided by 3, T2 divided by T1. What's 6 divided by 3? We get 2. What's 12? T3 divided by T2. What's 12 divided by 6? It's also 2. What's T4 divided by T3? 24 divided by 12. It's also 2. So we have a constant ratio of 2. Thank you very much, guys, in the comment section. Flores, thank you so much for the heart me. Really appreciate that. The support is much appreciated to those that can support when they can. Okay, so if we go back to the sequence again, thanks you, Hobson, for the rows. T1, term 1 is 3. What is that in terms of our general term? Remember, we said that the first term is A. So in terms of A, term 1 is A. What about term 2? Term 2, the second term, is 6. How do we get 6? We take the first term, we multiply by the constant ratio, 3 times 2. But what is 3? 3 is A. What is 2? 2 is my constant ratio. But to the power what? Just 1 2, not 2 2s, but 1 2. So that means, in other words, okay, 3 times 2 to the power 1 in terms of A and R. Term 2 can be written as A times R. In other words, AR. So term 2 in terms of A and R is AR. December, because, guys, do you know what? A Christmas surprise is coming. It's Christmas on the 25th. So what better time than for me to act as Father Christmas for our Black nation, our white nation, our South African nation, and start getting you guys geared up for what? For next year, grade 12. You are not forced to be in the live, as loquacious Sedima is saying. No one is forcing you to be here. So if you feel like you still want to be in the festive season and enjoy yourself, please, guys, slowly but surely use the screen, swipe through and go through to the next live session that is up. I think there are many DJs that are DJing at this time of the night, getting you into the Christmas vibe. Happy birthday, Beyonce, Beyonce, happy birthday, Beyonce, you know. So please, guys, don't feel forced to be here. Don't feel harassed, you know. If there's something within your heart that is saying, ish, this guy's harassing me by him doing this, I would love to be here, but the thing is, I'm enjoying my festive season. Please, guys, enjoy your festive season, but be here if you want to be here. You don't have to be here, but don't harass us with your comments, please, there in the comment section. Really, just please. Okay, so like I said, guys, term 2 is equal to AR. All right, in terms of A and R, term 2 is equal to AR. And the way in which we can observe this truly, guys, is if we come to the general term. If I go to the general term, this is Tn is equal to AR to the power n minus 1. If I substitute 1 here in the place of n, which means position, then it means that in the place of n here, I have 1 minus 1. And guys, we all know what 1 minus 1 is there in the exponent. 1 minus 1 there in the exponent means 0 in the exponent. So term 1 would be AR to the power 0. But guys, we know that a base raised to the power 0 is simply equal to what? It's equal to 1. So term 1 truly in terms of A and R for our general term of the geometric sequence is A. Term 2 is AR, because if I substitute 2 here, AR to the power 2 minus 1 would leave me with 1 as an exponent for R. So that is why this makes perfect sense that term 2 is A times R. Term 3, which is my 12 that is there, that is simply what? A, okay, which is 3, okay, times 2 to the power what? 2 to the power 2. So in other words, we know that A is 3, R is the constant ratio, which is 2. Then we know that in terms of A and R, term 3 is A because 3 is my A, times this 2. This 2 is my R, my constant ratio. R what? R squared. So that's why we say that term 3 in terms of A and R is A times R squared. I mean, we could always verify this. If we come here to the general term of the sequence, we substitute 3. What happens? This is T3, which is equal to AR. In the place of N, we substitute what? 3. What's 3 minus 1? It is 2. So that means term 3 is AR squared. So it makes sense that term 3 is AR squared. Term 4, AR to the power 3. Term 5, AR to the power 4. So it means that the term number or the term position will always yield a one number less in the exponent of R. Okay. Term 3 is AR squared. Term 4 is AR to the power 3. Term 2 is AR, but we know that there's an exponent 1, which is a ghost number. Are we making sense here? So guys, we need to know how to express our terms in terms of A and R, because A and R are important features in the general term of a geometric sequence. I repeat, Tn is equal to A. A is the variable that stands for the first term. R is the variable that stands for the constant ratio. And we know that the constant ratio we calculated by taking a later term divided by the previous term. A later term divided by the previous term. All right. And all in all terms need to be expressed. We need to know how to express all terms in a geometric sequence in terms of A. Term 1 is A, and R. Term 2 is A times R. Term 3 is AR squared. Term 4 is AR to the power 3. And so it goes. Generally speaking, the nth term is equal to the first term, which is A, times the R, which is my constant ratio, to the power n minus 1. So this would be the general term of my geometric sequence 3, 6, 12, and 24. Because in the place of A, I would substitute the what? The first term, which in this case is 3. And then in the place of R, I would substitute my constant ratio. How do I calculate my constant ratio? It is term 2 divided by term 1, term 3 divided by term 2. The same value, which is 2, is what I multiply to the previous term to get the next and the next and the next term. All right. So I don't know if there's any particular questions that anyone has, but I am happy to entertain any questions, because guys, at the foundation of understanding geometric sequences, we need to first understand firstly, what is a geometric sequence? It is a sequence where the ratio between the consecutive terms remains constant. This word consecutive is just a big word that means one number after the other in a sequence. So consecutive terms just means terms that follow each other. We say that the geometric sequence has a constant ratio. What is a ratio? A ratio is a fraction. In simple terms, a ratio is a fraction. So for instance, if we want to find out what the ratio is between 3, 6, 12, 24, which is a geometric sequence, we take term 2 divided by term 1. We take term 3 divided by term 2. We take term 4 divided by term 3. And we should find constant ratios that should emerge from that division. Okay, I hope you understand that, and I hope that's clear. Then we know that a general term of a geometric sequence is given by Tn is equal to the product of A and R, and r is raised to the power n minus 1, guys. Okay, n minus 1. And all we simply do there is whenever we want to actually find out what each term is in terms of a and r, we can always find what term 1 is in terms of a and r is by substituting 1, which is n, the position. Then we subtract 1 minus 1, which gives us, in terms of a, that term 1 is a. Term 2, if we substitute 2 here, 2 minus 1. Guys, that leaves us with an exponent 1. That means term 2 is actually going to be a times r, or in other words, ar to the power 1. Term 3, we do the same thing. We know that the exponent will be 3 minus 1, which is 2. So we are going to have ar squared. Term 4, guys, you get the picture, right? A times r to the power 4 minus 1, which is going to have the exponent 3. And then if we want to write the actual general term of this specific sequence, we write down what a is, the first term. We calculate the constant ratio. 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2. So therefore we substitute in the place of a, the first term, which is 3, substitute in the place of r, the constant ratio, which is 2, we raise it to the power n minus 1. This is the nth term, the general term of our geometric sequence of 3, 6, 12, and 24. Okay, I hope that makes sense, guys. Now, there it is. The general term of a geometric sequence is Tn is equal to ar to the power n minus 1, my beloved grade 12. Okay, yes ways, lucky, yes ways, and you are a lucky boy because you are here, or you are a lucky man, or whatever you are, lucky Spider-Man, for actually coming in. You can just throw me a nice galaxy there. You know, I think, like, I know you have a lot of money there. Just throw me a nice galaxy and you can be gone after that. Okay, here we are, guys. Next up, that general term of a geometric sequence can be used to determine the value of any specific term of the geometric sequence. The formula, when we have it, guys, can be used to determine the value of any specific term of the geometric sequence. Any guys, formula can be used to determine the value of any specific term of the geometric sequence. Okay. Additionally, the formula can be used to determine the position, in other words, the value of n. If we are given the value of the term, we can calculate its position. If we are missing the value of the term, we are given its position, we can calculate the actual value of the term. These are two things we can do when we are given the general term of the sequence. So the formula can be used for two things: to determine the value of any specific term, or it can be used to do what? To calculate or determine the position, in other words, n of any term in a sequence. How? We equate Tn to the what? To that given term value, and then we do what? We solve for n. And you know what, guys? Our laws of exponents become very important here. Okay, so those who were here earlier on today would have seen me busy with exponents and the laws of exponents. Okay, editors, like, can you please repeat? I didn't hear you nicely. Which part didn't you hear nicely, edits? Do you mean like I need to go back to the beginning and start all over? Is that what you mean? Or do you mean from this arrow, this particular page, right? Because I'm going to follow this up with the examples. Okay, now edits, you do realize that this is a time that now I have to take and go back, right? time that you are basically, that is freely given to you. Now you want me to go back and go back again, right? I think I will explain in conjunction. I'll explain as I go along, all right? Just allow me to complete the full trail of thoughts, and then I will return back, all right? Just hang in there. Okay, then here's something important, very important to note. To solve for an unknown in an exponential equation, we are going to have to use the following instrument and tool. Okay, and here is something that you need to just take into consideration as you listen to me. If b to the power x is equal to c, then the following is true. Then x, I'm not going to touch on sigma today. I'm only starting the concept of geometric sequence, so there's no ways I'll do sigma today. It will be an overload of information for people that are probably only hearing this for the first time. So 2,6, yeah, hope you heard me there. If b to the power x is equal to c, then do you see this guy, this exponent x? There it is. It is the subject of what I want to solve for. Then x, that exponent, is equal to, now, new terms or new terminology for maybe some of you have already been exposed to log. X is equal to log. Now, on the other side of the equal sign, you have c. So we say log c. The base of x here was b. So we say log c base b. Now I'm going to bring my calculator into view very quickly. This is an important concept because we are going to be using log a lot to solve for our unknown. We use this to solve for an unknown in an exponential equation whereby your base on either side of the equal sign is not the same. Guys, you know how to solve an equation that is an exponent when the bases are the same. You don't even need to use this approach that I'm just explaining now. When the bases are the same, you know that you can take the 4, change it to 2 to the power 2. When the bases are the same in exponents, what do we say, guys? When the bases are the same with exponents, we know that when the bases are the same, we keep the base, right? In fact, we drop the base, we equate the exponents. So the answer here would be x is equal to 2. Now, here, this idea or this concept that is here, it helps us when we have a situation where the bases, you can see this is 2, base 2. But look at this side. Is this going to aid us in getting a base that is the same as this one? 2 is a prime number, 5 is a prime number, but are the bases the same on either side of the equal sign? I'm sure you can see, guys, that the bases on either side of the equal sign, they are not the same. So what do we do in a situation where the bases are not the same, but we want to solve for an unknown? You see, we want to solve for x still. We use this concept, this idea of log, to help us solve for the unknown. I hope we are together. I hope you are seeing why this little key, this little rule here is so helpful. When the bases on either side of the equal sign are not the same, we employ the use of log. All right, and log, guys, is situated in your beautiful calculator. Look at this button here. You may have seen it many times in your calculator. You are asking yourself, what is this guy used for? Who is he for? Well, today, my brothers and sisters, I want to bring to your attention Mr. Log. Do you see him? Look at him. There. He's flickering there. You can see Mr. Log. Mr. Log wants to be one with you. Mr. Log wants to be friends with you. Mr. Log wants to become more acquainted to you. Mr. Log wants to be romantically involved with you. So you must allow him into your life. Open your heart and allow Mr. Log to become one with you. So there is Mr. Log, guys, and all that Mr. Log is saying, I am going to solve your problems. The ones where the bases are not the same on either side of the equal sign. If the bases are not the same, please use me. Use me. Use me and abuse me. Are you with me? So here we are, guys. We have 2 to the power x is equal to 5. How do we solve for x? We want x. Okay. In grade 10, you may have been exposed to what I would call the estimation and approximation. You would approximate a certain value, okay, which if you were to substitute in the place of x would be closely, able to give you something close to 5. But now we don't have time to approximate. We need specifics. So if we look at this thing, if b to the power x is equal to c, what is this saying? Take the exponent that is unknown, make it the subject of that particular equation. Then the c, it's fine on the other side. Introduce log into the mix and then take the base. It becomes the base for log. The base b becomes the base for log. So we have log c, which c was on the other side, base b, and x becomes the subject of that particular equation. So here we are, 2 to the power x is equal to 5. Remember, I said we make x the subject. 5 log 5 base, the base is 2. So you go to your calculator, guys. All you do is you simply say, voila, Mr. Log, you press that button. That appears. The base there is 2. So you write 2. There, you see, I pressed 2. Then you move your cursor. You go to this little section, you press 5. Then after that, you just say equal. Voila, there's the answer. So you would say here, x is equal to 2,32. Simply put. There is the answer, guys. There is the answer. I've simply used the what? I've applied this law that helps me to solve for an unknown variable exponent when the bases are not the same. I can simply use log to solve for the unknown. Okay, I need you guys to tell me in the comment section that we are with you, sir. You can move on, sir. We get you, sir. We may not understand fully, but I think it makes okay sense that b to the power x is equal to c. We can always solve an equation where the bases on either side of the equal sign are not the same by using log. This variable, say you said it becomes the subject. Yes, my child. This variable, my child, I said it becomes the subject. The unknown exponent variable that we are calculating becomes the subject. Then say you said that we introduce log next to 5. Yes, my child. Then we take 2. It becomes the base of that particular log. Yes, my child. Then, my child, you go to your calculator. What do we do there, my child? You simply go there to the button. It is the log button. Thank you, Luan. You press that log button. Then, voila, we see that, okay, there are 2 little boxes. The base box and the box that is for the number on the other side. All we simply do, we write it out. We go and press the little button. We know there is 2. We write 2. We press 2 there. 1, 2 only. Then we take our cursor, we move it to the right so that we can select the other box. We substitute there 5, voila, and then we say equal, and then voila. The answer for x is 2,32. All right. So please, guys, grade 12s, we now need to become experts in using log to solve for unknowns. Now, there is no exponential equation that will ever go behind our backs and try and do a number on us. We can solve exponential equations where we know we can convert the bases to be the same because we know what to do. We use our prime bases. But we also know how to solve exponential equations where the bases are not the same. So we are very well versed now and equipped to destroy many questions that come our way. Okay? All right, let's move on to an example. This example will help us now to be able to recap on all the concepts that we have covered so far. And other examples that follow will help as well. Here in this question, we are given 2, 6, 18. Happy birthday, Beyonce. Somerville. Yeah. Somerville, you can feel the vibe. I can see you. 2, 6, 18. Now, let us study the sequence. We have 3 terms, but what we want to see here is what type of sequence do we have here? 2, 6, 18. I wonder what is happening here. We are told that 2, 6, 18. Now we are asked to determine the general term. GT just means general term of the sequence. Sometimes they tell you what type of sequence you have, sometimes they don't. It becomes your responsibility to establish the type of sequence you see before you. Now, this is obviously not going to be an arithmetic sequence because there's no constant difference here. Grade 12s, feral. 2, 6, 18, there's no term that we are adding or subtracting to get the next and the next term. So this is not arithmetic. We think again, maybe it's geometric. Geometric sequence has a constant ratio. 6 divided by 2 gives us 3. 18 divided by 6 gives us 3. So this is a geometric sequence. It's important to first establish what type of sequence you have before you. Sometimes they will tell you explicitly in the question. Sometimes you'll be given a sequence and you have to establish it yourself because you know the type of sequences you are dealing with in grade 12. So determine the general term of the sequence. Our first term A is 2. R, on the other hand, we are going to have to use T2 divided by T1 and check it again with T3 divided by T2. What's 6 divided by 2? 6 divided by 2 is 3. What's 18 divided by 6? It is also 3. So in other words, that means our constant ratio is definitely going to be what? 3. Okay. Then we now want to find the general term. So we go and write our general term for a geometric sequence. Tn is equal to AR to the power n minus 1. Then we substitute. In the place of A, we write 2. There it is, 2. In the place of R in brackets, we are going to write 3 because we established that R is equal to 3. So it's 2 brackets 3 to the power what, guys? n minus 1. Done. Okay. Then some people usually go the extra mile if they want to, but if you leave it like this, guys, it's 100% fine. You can leave it like this. Some people will tend to write 2 and then they'll say 3 to the power n. They will separate 3 to the power n times 3 to the power negative 1. Then they will multiply the numerical values 2 times 3 to the power negative 1. Remember, 3 to the power negative 1 can be written as 1 over 3. So it's like saying 2 times 1 over 3, which is 2 over 3. Then you write 3 in brackets to the power n, and that is that. Guys, you would be fine if you left it like this, right? It's just that, I mean, of course, at the end of the day, if you want to simplify it to completion, leaving your answer so that there's no negative exponents, then you can say 2 over 3 brackets 3 to the power n. That's also fine. Okay, I mean, no difference. Next question, determine the 8th term. Now guys, you'll remember that in the previous statements above, I had said that we can use the formula can be used to determine the value of any specific term of the geometric sequence. This is that situation. Here we are being asked to determine the 8th term. What does 8th term mean, guys? It means we need to find T what? T8. So T8, which means in the place of n, we are going to write 8 because we want the what? The 8th term. By substituting in the place of n 8, we go to the actual equation or the general term. We write 2 brackets 3 in the place of n. We write 8 minus 1. What's 8 minus 1? It is 7. Okay, then we have 2 brackets 3 to the power what? 7. Okay, then it's easy, guys. You just grab your calculator. 2 brackets 3 to the power 7. Then you say equal, and then your calculator just gives you the beautiful answer just like that. So 4,374 is basically the value of the 8th term. All right, that's why this note says a formula, the general term or the general formula, can be used to determine the value of any specific term of the geometric sequence. So the general term or the general formula is useful. Finding the general term helps us to be able to find any term, specific term of the general sequence. So it's very important to be able to find the general term, to know how to find it, so that we can then be able to find any specific term in the sequence that is given to us. I hope that makes sense. Okay, all right. So even for someone who was asking me to go back, hopefully you now are caught up, understand, and you can hear me now when I say to find the general term, we use this formula. We find A, we find R, we substitute, we write Tn. To find a specific term, we substitute back in the formula, we get that specific term, and it's as simple as that. All right, so guys, these should really not be that difficult. It should really just be nice, free-flowing mathematics. Okay, if there's any questions, I expect you to actually ask those questions if there be any. Okay, all right, let us now look at the next question. In the same question, it says which term is equal to 1,458. It is asking us which term is equal to 1,458. So I'm just gonna back up a little bit and see if we can't then go back. Remember, we said Tn is equal to 2n minus 1. Now we are asked which term is equal to 1,458. Now, in order to do that, okay, if we go back to our notes, as me, I like, the second bullet point says the formula can be used to determine the position of any term in a sequence. How do we do that? We equate Tn to that specific given term value, and then we solve for what? For n. And in some instances, we need to remember the laws of exponents and remember the log law. So let us just go ahead now and see if this will even require that in this situation. So Tn is equal to 2 times 3 to the power n minus 1, and they said to us 2 to the power 3n minus 1. That is our Tn. So we said in order to solve this, we first take Tn, we equate it to the value of the term. Okay, we take Tn, we equate it to 1458, which is the term. We're asked which term is equal. Remember, the question was which term is equal to, right? That's what the question was asking. Which term is equal to 1458? So we take Tn, we equate it. Tn is actually 2 times 3 to the power n minus 1. That's what Tn is. Remember, that is Tn. We equate it to 1458. So we substitute in the place of Tn this 2 times 3 to the power n minus 1. Then we say equal to 1458. Then now we need to solve for n. So we deal with this question as we normally would when dealing with an exponential equation. Grade 8, we did this. Grade 9, we dealt with exponential equations. Grade 10, we dealt with exponential equations. Grade 11, we dealt with exponential equations. Now we are in grade 12, so we should be well versed. So the relationship between this 2 and this 3 to the power n minus 1 is one of multiplication. So what we first do is we divide both sides by what? By 2. Okay, to get rid of the coefficient there. Okay, so that leaves us with 3 to the power n minus 1. And then this side, what's 1458 divided by 2? I'm going to allow you guys in the comment section to help me out with the calculation there. 1458 divided by 2. Do we have any quick people that can just give it to me? Lollipop, lollipop, lollipop vibe. Lollipop Vutomi Mangwane. Oh, Ngwanesu. Oh, my little boo-boo. My little boy there. Switch on. January is coming up. That's what I should be saying back to you. Switch on. January is coming up. Okay, 1458 divided by 2. Thank you so much, guys. It's 729. Then you will remember now we check if it can be converted. 729 is equal to, we press what? We press shift, then we press what? Fact, to just see if this can be expressed in exponential form. Do you still remember that, guys? Because this is important, right? Yes, 3 to the power 6. 729 can be written as what? 3 to the power 6. 3 to the power 6. Okay, do you see that, guys? Yes, so because this one has same bases, then what do we do? The bases are the same, guys. This is 3 to the power n minus 1. This is 3 to the power 6. The bases are the same. So what do? We drop the bases. We equate the exponents. Then we solve for n. 6 plus 1. N is equal to 7. The real Nzizwa. Yes, you are definitely the real Nzizwa there. The real Nzizwa. You are the real Nzizwa indeed. N is equal to 7. It is 17 minutes past 12 and people are up doing maths. Wow, this is beautiful, guys. This is beautiful. This is like, yo. You don't mess. You don't mess. You don't mess. You don't mess. Okay, there we have it. You see? So I hope you guys can see that. Okay? I hope you see that. Mr. Virtue is like on my case there in the comment section. I don't know why. The parts that I'm covering right now, I'm covering geometric sequence. I'm just going to be covering geometric sequence because of the short nature of the video that I did, which is on my YouTube channel. Just wanted to sort of like extend that. Okay. All right. So I hope that makes sense. That example just makes beautiful sense. Now you see. No, just sequence, not series. Sequence, guys. Sequence. Yeah. Okay. All right. Now let us venture forward. Let's just venture forward. Okay, look at this one now. Let's move on. Consider the general sequence. 12 minus 6, 3, and then negative 3 over 2048, which is like the last term in the sequence. Determine the general term. So how do we determine the general term? We've got 12, we've got minus 6, we've got 3. The sequence goes on to the very last term, which is negative 3 over 2048. And so the question there is determine the general term, and that's the first question that is there. So let's just write down the sequence. We have 12 minus 6, we have 3, and what they want there is the general term of the what? Of the sequence. Okay, so A, we can see here, is 12. What type of sequence is this? We said we are told consider the GS, so we are told it's a geometric sequence. So we know that, okay, this one, it's geometric. Okay, there's no doubt about it. Okay, since it's a geometric, we know that we are going to calculate the value of R, and our R value, we are going to say T2 divided by T1, which is minus 6 divided by 12, which gives us a negative half. Guys, we know that that's the case. Okay, A is equal to 12, R is equal to negative a half. Okay, and I mean, we could check it by T3 divided by T2, it still gives us a negative half. So negative half is really the constant ratio in the sequence. Now we want Tn. Okay, so we know that we're gonna say IR to the power n minus 1. We write down the general term of a geometric sequence generally. Then we substitute. In the place of A, we write 12. In the place of R in brackets, we write negative half. We raise it to the power n minus 1. This is the general term of the sequence, and we are very happy. Okay, 12 into negative half to the power n minus 1. The next question says, what is the sixth term? The next question says, what is the sixth term? So if they say, what is the sixth term, we know we want T6, and therefore we know what to do. That when we want T6, we simply go to the general term, we substitute in the place of n the 6, and then we know that in the actual expression itself we substitute 6. Then negative a half, we close that bracket, then we write that exponent, the 5 there. Luandle has already got the negative 3 over 8. Thank you, Luandle. You got negative 3 over 8 there. That is term 6. These people. Guys, none of you are ever satisfied when you come into my life. There are people that come here, look at Mzala Knowledge. When will you do series? When will you do this? Guys, I'm currently doing what I'm doing. Can't you just be here for what I'm doing? I don't know when I'll be doing what you are asking me. All I know is the present. The future will take care of itself. All I know is what I'm currently doing, guys. Okay, the past is behind. I want to learn from that. The present is here. I am enjoying it. Let me enjoy my Christmas present, please. T6 is equal to negative 3 over 8. The next question says, what is which term in the sequence? The question says, which term in the sequence is equal to 3 over 256. That's what they are asking. Which term in the sequence is equal to 3 over 256? Okay, so guys, I'm sure you can see that to this question, how would we go about answering it? I'm sure now you've kind of gotten into the swing of things. Okay, and the funny thing is, learners tend to confuse these two questions around, so we need to see which one is asking for. This one was asking for a value of a specific term. This one is giving us the value of the specific term. All it wants is the position of this term. So these are things we need to make sure that we are clear about when we answer these questions, all right? Because so we know that we are going to have to equate Tn with 3 over 256 because this is a value of a term, all right? Tn is already given to us, so we know it's 12 to the power what? N minus 1. Makes sense? Which is equal to 3 over 256. Okay, then when we are here, that's when we apply our grade 11 and grade 10 exponential equation theory. The 2 here is a coefficient of this entire thing, so we divide both sides by the 12. Okay, so that's going to leave us with negative half to the power n minus 1. So that means if we divide by 12 and it disappears, it means 3 over 256 divided by 12. Okay, that's what we care about. 3 over 256 divided by 12. That gives us 1 over 1024. 1 over 1024. Okay, I hope that makes sense. Then, okay, we can see base 2 there, all right? And in actual fact, it would be nice if we could actually make this have a base 2 as well. So we go to our calculator and we say 1024 equal to, we have shift, then we have fact. That gives us 2 to the power 10. And guys, simply put, 1 over 2 to the power 10. Think about it, right? Okay, this means we can, if we wanted to, we can see that the base here is negative half. So we can actually make this base as well become negative half. Then this exponent 10 can be written external to both the numerator and the denominator. So we have 1 over 2 still, but we've just put a negative half, which then is raised to a even exponent. Now guys, when we raise this to an even exponent, remember, an even exponent, when applied to this negative, will change it to become the positive that it was initially. All right, so this is just tricks of the trade that we apply, because what we want at the end of the day, we want to have the same base on either side of the equal sign. Why? So that we can then drop the bases and equate the exponents. All right, so I want to repeat this again. People are going to ask, where did I get the negative sign from? Like I said, this is 1 over 2 to the power 10. Okay, remember, if I take the 10, that it is external to the fraction. All right, remember, if I apply the exponent 10 to 1, it still gives me 1, because 1 to the power 10 is 1. If you take the 2, raise it to the power 10, that's what gives me the 1024. But remember as well that if you apply the exponent to a negative sign, what happens to the negative sign when you apply an even exponent to a negative sign? When you apply an even exponent to a negative sign, then it becomes positive. All right, so that is why this works out nicely, just like this. Okay, bases are the same. You can drop the base, equate the exponents. So I have n minus 1 is equal to 10. Then I can solve for n. 10, take the negative 1 over to the other side, 10 plus 1. So n is equal to 11. Okay, so I hope you understand this very well. Freeside Quest, if you can stop spamming our comment section there with your McLaren series or Taylor series. If you are sensitive to what's happening, you would actually see that this is actually sequence and series in progress for grade what? For grade 12. And so, I mean, of course, I hope you would respect that and not spam us with your constant messaging there. It's not appreciated. Thank you. Yeah, so n is equal to what, guys? To 11. Okay, and we're doing geometric, so please yeah, any other series right now is not really of our concern right now. Okay, I hope it makes sense. Okay, guys, I hope we are fine. N is equal to 11 there. Okay, that's basically it. Then the next question says what is the position of the last term in the sequence? What is the position of the last term in the sequence? So currently, this is the last term, minus 3 over 2048. So we want to find out what is the position of the last term in the sequence. So in the same way, guys, just take Tn, we equate it to the value of the last term. Okay. And it's no different from what we've just done now. We take Tn, okay, there it is. We take that Tn there. Then after this, what do? We divide both sides by 12 because that's the coefficient, okay? So that will leave us with that. Okay, take your calculator. What happens when we take a negative 3 over 2048 and we divide it by 12? This is what we get. Okay. We get a negative 1 over 8,192. So let's go a negative 1 over 8,192. So this is already negative, okay, which makes it very nice because that means we're not going to have to worry. So hopefully the exponent for 8,192 is going to be odd, okay, so that we can retain the negative sign that is already there. So we go to 8,192 and we say equal, we say shift, we press fact. Remember, we want to look at the prime base that actually comes about from 8,192. It's 2 to the power 13. So that's odd, guys. So that's actually good. 1 over 2 to the power 13. Okay. Then all we can simply do nicely there is take that negative 1 over 2, take the exponent that is 13, put it on the outside, because an odd exponent, unlike an even one, an odd exponent is not going to change the sign. Okay, when we apply the odd exponent to negative, it stays negative, so it still retains its original identity, which is sweet. Okay, and remember, this exponent 13, I can place it outside because the numerator value is 1, and 1 to the power 13 basically still gives me that 1, whereas 2 to the power 13 in the denominator will give me that 8,192, and this negative sign remains unaffected when we apply the odd number exponent. Okay, so these are all valuable things. Because when we know these things, it helps us out. See, remember what I did here? I introduced a negative sign because I knew that by placing a even exponent outside with the negative sign that is already there, that is basically going to what? That's going to assist me in having same bases so that I can drop the base and equate the exponents. Remember, same bases means the sign as well needs to be the same, not just the number. All right, so here we have both the fractions having the same sign, so the bases are now the same. We can drop the base and we can equate the exponents. So n is equal to what? 14. So it is the 14th term, guys. Okay, so the 14th term is actually equal to negative 3 over 2048. It is the 14th term. Okay, guys, are we catching on to this? Is it really, like, are we starting to like be fine, you know? So exponents become an important conceptual, you know, we hold on to that pillar of exponents, because if that pillar of exponents is fine, then basically this will facilitate geometric sequences being fine as well. All right, you're not going to have too much of a problem there. All right, yeah. Now, geometric sequences, guys, are not only limited to actual numerical values. There are questions for geometric sequences that involve variables. So for example, x plus 2, 3x plus 1, 7x minus 1, we say that is a geometric sequence. And the question is, determine the value of x. The value of x. If x plus 2, 3x plus 1, and 7x minus 1 are a geometric sequence, the question is, determine the value of x. So what would we then apply, since we know that this is a geometric sequence? What concept can help or aid us in being able to find the value of x, given our understanding that this is a geometric sequence? What concept would we have to apply? Zivaliwe izikolo but zivuliwe ingqondo, Simpiwe. Yeah. Thank you, Mzala Knowledge. Mzala Knowledge, you are knowledgeable, Mzala. Yeah? You are knowledgeable, Mzala. Find the R. So we basically use the concept of R. Because we know that the constant ratio for geometric sequence is a constant, we use that conceptual understanding, and that aids us in being able to calculate the what? The value of x. So we are going to equate T2 divided by T1 with T3 divided by T2. What's T2? 3x plus 1. What's T1? X plus 2. What's T3? 7x minus 1. And what is T2? 3x plus 1. Okay, so there's the concept. The concept of constant ratio is used. Why? Because we are told that the sequence is geometric. Had the sequence been an arithmetic sequence, AS, not GS, what concept would we have used here to find the value of x? If the sequence was a arithmetic sequence, what concept would we have used to calculate the value of x? In this case, the sequence is a geometric sequence. But what if it was an arithmetic sequence? What concept would we have used to basically calculate the value of x? Thank you, Mzala. Okay, thank you, Lux. Okay, you guys get it. Okay, so we will definitely have used the what? The constant difference. All right, T2 minus T1 is equal to T3 minus T2. That's what we would have used. And then, guys, algebra would have had to kick in. Thank you, Dime. Thank you. Loquicious. Is it loquicious? I don't know how to. I'm just gonna call you Loco. Loco. All right, so algebra, guys, algebra when we are here. Okay, so now we can just simply do the cross multiplication game. Honestly speaking, I find that is more delicious to the soul. we do the cross multiplication game. All right, 3x plus 1. Like we said, Neptune, the schools may be closed, but our minds are not closed, forever open. Our minds are forever open. Just like a game is never closed. Yeah, do it indeed. Because maths is a game, guys. Maths is a game. It always has been. The love of the game. 3x plus 1 times 3x plus 1 is equal to 7x minus 1 into x plus 2. Then we play the FOIL game, guys. It's just FOIL. FOIL on the left, FOIL on the right. 3x times 3x. I'm sure you guys are doing the maths. Then we know 3x times 1 is 3x. 1 times 3x is also 3x. The addition of the 2 gives us 6x. I hope you all understand how I got 6x as the middle term. Then we multiply the last term. That gives me plus 1. Okay. Equal. We go to the other side. We do the same thing. First, 7x times x. We get 7x squared. 7x times 2 gives 14x. Minus x. That gives you 13x. Hopefully you guys understand how I got 13x. We add and subtract the middle terms. Okay. And then negative 1 times 2 gives us negative 2. Now we play with like terms. Make sense? Like terms, we transpose. 9x squared and 7x squared, they become gym partners. 6x and 13x become gym partners with the sign, and then plus 1 plus 2 become gym partners. And then 9x squared minus 7x squared, we know gives us what? 2x squared. 6x minus 13x, we get a beautiful what? Negative 7x. And then lastly, 1 plus 2, we know it is 3. Then of course, some of you may decide to use the quadratic formula. I have no qualms against that formula. If you want to use it, go ahead. But some of us, we may be well versed in being able to factorize, all right? And therefore, that basically gives us a beautiful answer of the following values. 2x is equal to 1. X is equal to 3. We divide both sides by 2. We get x is equal to a half. Or x is equal to a 3. Those are the values of x for those that basically would want to know. Standard form, factors, or some of you may decide to use the quadratic formula. That's fine. Zero factor law, we get our roots. Okay, standard form, factorization or quadratic formula if you want. So if you factorize zero factor law, remember the zero factor law only applies when there's a product of factors with 0 on the right hand side. We take each bracket equated to 0. We solve for the independent roots. We get x is equal to 3 or x is equal to a half. All right. Okay. You see, now we are also bringing back our algebra. Okay. Yeah, I know, Neptune. Hey, it seems like a lot of people like doing that, but it is not necessary, right? It really isn't necessary. Your paranoid self would do that because you want to make sure that you've gotten 100%. But honestly speaking, if you have done every step in the way that it ought to be done, then there shouldn't be a need. All right. Now, guys, let me just be honest with some of you. If some of you get the concept of constant ratio and you are able to get to this step, then it means that you are fine for sequence and series. If you are struggling with this part from here up until the end, then it means that your problem is not with sequence and series in grade 12. It is with what? It is with your algebra, solving a algebraic equation in fraction form. You have a problem and you must look at where your problem is. Is it with FOIL? Do you have problems with multiplying, adding and subtracting like terms? Do you have a problem with getting an equation to standard form, meaning you have a problem with adding and subtracting like terms? Do you have a problem with factorization? Because if you do, the quadratic formula is there. Do you still have a problem with the quadratic formula, using the quadratic formula to solve for x? Okay, and then getting the values of x. So guys, we need now to be very sensitive to what our problem may be, and then once we know what it is, then we need to make sure we iron out that problem. It can't continue to be a persisting problem. Once you've identified a problem and it continues to be a problem, then the problem is not the problem, you are the problem. Man, don't I just love hearing myself say such things, eh? Yeah. I think those are very nice, problems that we just did. You want to see the previous page? What do you want to see about the previous page? You press. What do you want to see? What do you want to see? Yeah, pressy way. What do you want to see? Super. 1.3, there's no problem. 1.3, even for maths papers, is fine. Okay, it's fine. Are you sure? All right. Man, yeah, I feel so small because sometimes I feel like I'm in the presence of greatness in this live. You have people like, some of these people that are here that like got your 90 something % at the end of the year, grade 11 last year. End of the year this year, sorry. I almost feel like I've already crossed over to 2026. And then you have to deal with these people that get high 90s in your live session. Hey. Anyways, anywho. Yeah. So yeah, guys, those were, yes, I think that was pretty much, yeah, man. You guys need to practice now those types of problems, this geometric sequence, and you must grab your textbooks, practice. I think I've basically exposed you to the fundamental basics for geometric sequences. The different types of questions you can anticipate and expect. I just wanted to actually do one question that has to do with geometric sequence. So just so that I can actually hammer the idea that I actually expressed earlier on about being able to state the term in terms of A and R and so forth, because that was something I had explained earlier on today, right? I explained that earlier on. So let's try and find okay, just one last. The third term of a GS. The third term of a GS is 5, and the sixth term is 135. Calculate the first 3 terms and the nth term. Okay, just to kind of wrap up today's live session. So here we have, guys, There's a question here. It says that the third term of a geometric sequence is 5. So that's the third term. The third term is 5. And the sixth term is 135. And the question goes on to say, calculate the first 3 terms of the sequence. Okay, sorry, not the first 3. It would be the first 2 terms. Okay, because the third term we have, and the nth term. Thank you, Mzala. Mzala seems to be Mzalad. Okay, so why am I actually looking at this question? Because remember, earlier on, I was on your case about the following point, and I just want to go to that point because it is in focus. Remember here, I said to you guys that we need to know how to write the terms. Term 1 is A, term 2 is AR, term 3 is AR squared, term 4 is AR to the power 3. So what we are finding is that each term, okay, for R is going to be 1 less than the position of the term. So that's why, for instance, this is AR. It's not AR squared, but it's AR to the power 1. Here, 1. This would actually be AR to the power 0 if you are to be practical about it, because R to the power 0, any base raised to the power 0 is 1. That's why we say term 1 is A. Okay, but I mean R to the power 0 would be a good indication of the term in terms of A and R. Term 2 is AR, term 3 is AR squared, term 4 is AR to the power 3. Term 27, let's see in the comment section if you guys get the concept. Term 27, what would be term 27 in terms of A and R? What would you write it as? Term 27. Let me just write a few and see if you guys understand this concept. Term 193. We have 3 of these. I want these in terms of A and R. So term 27, what would be term 27 in terms of A and R? Luandle Ngobese says AR to the power 26. That's term 27. Okay, I'm guessing people agree. Silently they do. And I hope you guys get the point, because if we are saying 1 less than 27, then that is 26. So that would be AR to the power 26. So Luandle, you're 100% correct. Term 65. What would be term 65? Seems like Luandle is the only one that's actually up and awake. Luandle, you don't want to sleep, do you? Thank you, Mzala. Term 65 is AR to the power 64. So hopefully you guys get the point. AR to the power 64. Then lastly, term 193 in terms of A and R. Thank you, Loco. Thank you. AR to the power 192. Okay, you guys get the point. You guys are 100% spot on. So we are coming here now. They are saying the third term of a geometric sequence is 5 and the sixth term is 135. Calculate the first 2 terms. The first 2 terms and the nth term. So we want 2 things up. We need the first 2 terms. And after calculating the first 2 terms, so 1, we are going to set up equations. So term 3, AR to the power 2 is equal to 5. That's equation 1. Term 6 is 135. AR to the power 5 is equal to 135. Right? That's equation 2. So we set up the equations. That's step 1. Step 2. Yes, Lwandle. That question, you can change that question to a statement. I divide the two equations. I divide the two equations. Divide two equations. Why? To eliminate one variable. Divide the two equations. Why? To eliminate one variable. What's the one variable that will be eliminated when you divide the two equations? Right. So hopefully you guys can see what will be eliminated. So I'm going to give specific instructions. Equation 2 divided by equation 1. In other words, equation 2 divided by equation 1. This divided by that. A divided by A is 1. R to the power 5 divided by R to the power 2. Remember, when the bases are the same and you're dividing, what you do, you subtract the exponents. So I said 2 divided by 1. That means R to the power 5 divided by R to the power 2 gives us R to the power 5 minus 2. Then what's 135 divided by 5? Okay, so I hope you can see this division that's happening. On the left, you divide A divided by A, that's 1. Okay, that's like saying a to the power 1 minus 1, which is 0. A to the power 0, but A to the power 0 is giving you still what? A 1. Okay, so that's how we eliminate one of the variables so that we can solve for the other. Okay. Okay. Yeah. And it's the relationship of the variables together that leads us to dividing. The relationship between A and R is one of multiplication. All right. And the only way we can see that we can eliminate one of the variables if we divide. Subtraction is not going to help me with that, but division will. All right. So I divide, okay, and then I get R to the power 3 is equal to, what's 135 divided by 5, guys? Okay, I'm just going to give you guys a chance to actually tell me what 135 divided by 5 is. Thank you, Mzala. Mzala, Mr. Knowledge, is quite resourceful there in the comment section. Thank you, Lwandle. Thank you so much. So that's 27. Okay. And then to make life very easy, we just take that root, the cube root. So R is equal to what, guys? R is equal to 3. So R is 3. Once we have R, it's easy to find A. Step 3, we substitute R into any of the two equations. Okay, any of the two. So I'm going to substitute R is equal to 3 specifically in equation 1, because I can see equation 1 okay, so I'm going to get 9A is equal to 5. We divide both sides by 9, so A is equal to 5 over 9. Okay. 5 over 9. First two terms, 5 over 9. We multiply 5 over 9 by 3. What happens when we multiply 5 over 9 by 3? We get what? 5 over 3. So these are the first two terms, firstly. Then next, we find the nth term, because remember, we are supposed to calculate the first two terms and the nth term. Tn is equal to A 5 over 9. R is 3 to the power n minus 1. Okay, I'm done. We're done. Okay, cloud number 9. Is cloud number 9 someone that was here in the live session, or is someone that just came in and is just making funny faces for no funny face reason? I see your funny face there, Mr. Cloud number 9. Okay. Right. Any questions? Any questions whatsoever, guys? Because if there's not any questions, guys, then for today, I'm going to hold my horses right there. Okay. I'm going to hold my horses right there. And I'd like to encourage you to actually, like I said, try and get into your textbook, get some exercises done. Yeah, because remember, for this question we wanted the first 2 terms, okay? Just the first 2 terms, because the third term we already have, okay? Yeah, third term is already there. We wanted the first 2 terms, so that's why I've written 5/9 and 5/3. T3 is 5. You are 100% correct. It helps exactly here, Lwandle, when you are solving simultaneous equations, when you are required, okay? Yeah, T3 is equal to AR to the power 2. It helps you exactly here in these types of questions, all right? Where you are actually required to find, terms of a sequence, and you are just given randomly, scattered terms in a particular sequence, but they are scattered everywhere. And all you want to do is you actually want to find what? You want to find the value of A, which is the first term, and you want R, so that by so doing, you can actually find the first 3 terms of the sequence, and ultimately, you can find the general term of a sequence. So whenever you are given the 3rd term of a geometric sequence is that, or the 10th term is that, remember 10th term, AR to the power 9. You utilize this knowledge in being able to assist you to actually finding the terms of a sequence and also the general term of a given sequence if the terms are scattered everywhere. I hope that makes sense. Okay, I hope that makes sense. So guys, I'm gonna hold it right here for today. Thank you for joining in. It was really nice having all of you. Thank you for the gifters. Thank you, Lwandle. I really appreciated the you awesomes that you had sent earlier on. I know it was quite a while ago. I thank you a lot. So I really appreciate as well. Thank you so much for those amazing sweet roses, all 8 of them. I appreciate every one of them. I hope this was helpful. Yeah, guys, and I can never say what time tomorrow. I may probably see you same time tomorrow, like later on in the evening. You just need to make sure that all the things that need to be subscribed, or what you may call following notifications that people usually get for their favorite live creators when they go live, you have those activated and accessed, so that when I go live, you can be notified and when I come on. Yeah, my whole point of doing these things so that I can obviously help lay the foundation for you guys for this coming year 2026. I do want to also just say to the grade 12s that are here, guys, you are actually going to be the last group to write the grade 12 syllabus as you know it. You are going to be the last group to write the grade 12 syllabus as we currently know it. Okay, I know this from good information because I was part of the team that was marking papers at the marking center this year, all right, 2025. So the grade 12 group that is going to have their results announced next year, that grade 12 group, when they have the results announced for their mathematics and for just their results in general, you guys are actually going to be the last group. The exam guideline for grade 12 mathematics is going to undergo revision this year. It's going to be reviewed this year, and there are going to be changes that are going to actually come about with the exam guideline as we currently know it. So the 2026 grade 12 cohort group for mathematics, you guys are going to be the last group that is going to write with those exam guidelines that you currently know. You are going to be the last group. And let me say this, they might want to end the year in style with you guys. All right. And because they might want to end the year in style with you guys, you need to be very much clued up with what is happening in that exam guideline. But more so, please also give yourself some time to look at the past papers, especially the past papers that have been written in the past since 2014, guys. Because CAPS, as we currently know it, started in 2014. So from 2014 up until now, you need to look at the style of questioning and the questions that have been asked. Make sure that when you finish a section of the work that you are currently doing, some of you are busy in this holiday, and I'm very proud of you for doing that. So I know some of you are busy, you are covering the syllabus, you are, I have a group, for instance, on WhatsApp, where I was engaging some of my other maths gamer learners, and they were telling me that, say, I'm already done with sequence and series, and I said to them, I have a surprise for you. So I sent some of those learners the surprise that I had for them, just so that I can ascertain what's actually happening with that content. So you guys need to then make it a point, please make it a point that you you utilize these past papers, please. Also, 2025 paper, especially maths paper 1, it really shocked the grade 12 group that has just completed. It shocked them a lot, because that paper, presented difficulty that it has never yet presented before. A lot of matric learners were crying about it. So what you need to do is you need to prepare yourself adequately and properly, which is why I feel like I'm proud of learners that are using some of this time in the holiday to prepare, because you need the time. The minute schools start next year, guys, there's just going to be so much to do all at once. And it's always a blessing when you can actually make it a point that you start easing the anxiety for yourself by making sure that you are covering some of the content very early and now. All right, so this is a blessing. Thank you so much for all the gifts. I really appreciate it, sir. Like, too much. Your gifting does not go unnoticed. I really appreciate it. So please, guys, take it one step at a time, do a little bit at a time, and like I said, lessen the amount of pressure for yourself for next year by making sure that you are doing the little bit that you are doing during the holiday. It will pay great dividends, I promise you. But please do not become relaxed the minute the year begins next year officially for school, because some of you will think that you've done a lot during the holiday, and then you will fall into a very dangerous place of complacency. Do not ever allow yourself to fall into the trap of complacency. Make sure you retain the momentum moving forward. Let this start a new character habit for yourself, one of consistent working. You have the entire year next year to really just showcase some of your best performance that you've ever seen, ever. So please, I want to encourage you, I want to commend you. I know some of you are studying under adverse conditions. I know some people, you wake up in the morning, you are covering life science, you are covering geography, you are covering all these physical science, you are work energy, this that. Some of you are watching videos, Kevin, maths and science. Some of you are watching videos, video after video, and some of you are coming under intense criticism, like your own family. Some of your own family are going to be like, Aibo, guy, it's holiday, relax. And when you know exactly the fact that you are working towards something amazing. Some of you were shocked by your own report for grade 11, and you are not happy with what you got. So you want to make this dramatic comeback for 2026, and you don't want to leave any stone unturned. I respect that. So don't allow anyone to veer you off, or to distract you from what you have set your mind and your heart to. Don't allow anyone, and that includes yourself. Don't self-sabotage yourself even with your own thoughts, your own feelings, your own emotions that can sometimes work against you. So yeah, that's just all that I want to say for now. Everything else that I will say in future live lessons when we have them. Otherwise, yeah, you can maybe anticipate that tomorrow sometime. Like I said, I don't know when, because like I said, guys, I don't really, yeah, it's busy, and sometimes the time is available, sometimes the time is not. Okay, guys, thank you so much. Let me love and leave you from your best maths gamer, maths host. See you again when I see you. Cheers. Good night.